So we have the Taylor test kit, the blue box that has all the different things that we need to do in there. And this is what your kit's going to look like. And I try to tell people is you have two things in here that can be your best friend, and a lot of people don't even know what they are. And one is the instruction booklet. I challenge everybody who's got a Taylor test kit or can get their hands on it, read that instruction booklet that's in there, and you can find more useful information in that instruction book than I can give you in a seminar using the National Swimming Pool Foundation and the thick book they have. There's a lot of great stuff in that Taylor test kit instruction book that'll help you navigate it. I know when I had a Taylor test kit and I first started taking care of a pool, I opened it up and read through it. I could pronounce the words, but if you asked me a question about it, I really couldn't understand it. And it was kind of Greek. So after you get affluent and you've taken a certified pool operator course, the test booklet will start to make a little more sense. And then factoring water balance. Factoring water balance and balancing water was developed by a professor doctor in chemistry, and his last name was Langelier. So they refer to this as the Langelier Saturation Index. And we're going to do the worksheet that he put up, but then I'm going to take and turn those numbers into this wheel and then show you how to use this test kit and this wheel to do a quick analysis on how to read this wheel properly and how it works and what we can do to get through it. And that's what your saturation index worksheet looks like. And I wish, again, somebody would have taught me to keep the water balanced. And when I say I want the water balanced, what does that really mean? I want balanced water. What does that mean? A lot of people think, well, it means all the chemicals. And, you know, when okay, well, what chemicals does it mean? And the one thing about the saturation index when we're working it, if you'll notice, you got pH, temperature, calcium, alkalinity, and total dissolved solids are referred to as TDS or total dissolved solids. What's missing? There's nothing to do with chlorine in this water. So your sanitizing agent has nothing to do with how to balance a pool. And what I'm really trying to do when I balance the water is find the water's chi and its harmony and in its happy place, where the water in our pool is not aggressive. It's not actually chewing up or aggressively seeking and going after and chewing up the shells and motors and pumps and the sides of our walls. Or we're not trying to get it so dull that it's scaling, it's leaving deposits behind, and you get that white film that builds up on the tile that you can't scrub off, and it just gets embedded on there and it just gets this white crust. It means that our pool is scaling. So if we can get all of our parameters that we're talking about in the ideal range, the pool does not have any choice but to be balanced. So once we do all the tests that we're going to do and we record these numbers, I'll show you how to calculate and do the saturation index, but then I'm going to take and convert it over using the wheel that's given to you, or the saturation index that's given to you in the Taylor test kit, so that it can be done easy without having to learn a lot of new math. Don't know if you can see this, but I do have a gallon of pool water in a bucket. And the first test I'm going to do is I'm going to check for my chlorine level. And I want to take it to the 90 milliliter mark. And in a test kit, I can usually pull somebody's test kit and find out what they're testing for. But you're going to use reagent number 1 and reagent number 2. And when we add the reagents, we always want to go in a vertical straight up and down position. So 1, 2, 3, 4, 5 drops of number 1, swirl, and then 5 drops of number 2. 5, and then invert the cap, put the cap back on. Don't put your hands over the reagent and shake it. It'll influence the test by the oils and everything that are on your hands. So make sure you cap it. And then I am going to put a white background, if you will, behind it and show you that I've got a chlorine reading of about 4.0. So that's how you test for the free chlorine. But there's also a third reagent inside of your test kit that nobody uses really, and it's reagent number 3. And then what I would do is to that same sample that I have is I'm going to add 5 drops of number 3. 1, 2, 3, 4, 5. So I've added 5 drops, and what's happened at this point is there is no color change. So at this point, my free chlorine reading was 4.0, and then my total chlorine reading is 4.0. So both those numbers are the same. So 4 minus 4 is 0. That means I have 0 combined chlorine. Combined chlorine is usually not going to be a problem on anybody's outdoor pool. And combined chlorine is chlorine that's gassing out of your pool. And what controls combined chlorine is simply UV light and sunlight. So on an outdoor facility, it's always exposed to the outdoor with plenty of ventilation. So you're never going to get that chlorine smell gassing out of your pool, except for maybe first thing in the morning. You walk around the pool before the sun's come up and you smell some gassing chlorine. But by the time the sun comes up, it's all gone away. But if I was smelling chlorine gassing out of a pool, we only have one problem in the pool at that point, and the problem is we don't have enough chlorine. If you do have combined chlorine in the pool, the problem is you don't have enough. You would have to shock the pool, superchlorinate, or break point. In other words, break up the combined chlorine. And what's happened is the chlorine starts getting low and it combines with the nitrogen waste in the water, whether it's body oil, sweat, urine, different things that get into a pool, and it combines with that nitrogen molecule and it starts gassing out of the pool. So once I shock it, what I'm doing is I'm busting that nitrogen molecule off of the chlorine molecule. Now the nitrogen can gas out as a nitrate and you won't have any smell to it and the chlorine stays in the pool. So just remember, if you're having chlorine smells or issues, and especially with indoor pool, the problem is you don't have enough chlorine. I know you're thinking, well, that doesn't sound right, but that's the correct answer, is to shock the pool when you smell the chlorine coming out. So we've got our sample, and somebody will note that we have 4 parts per million of chlorine. Now I'm going to test for the pH. And the pH is done in the large milliliter vial, the large cylinder, and we're going to bring it up to the 44 milliliter. And now that I've got that in there, we're just going to use 4 drops of the pH or phenol red indicator. 1, 2, 3, 4, and I think I said 4, but it's actually 5 drops. And now I'm going to swirl the sample with the cap in place and compare it. And it does appear that my chlorine sample is slightly elevated, or my pH is slightly elevated. So I really want that sample to not be pink or reddish. I want it to be more of an orangish color. So at this point with a high pH, what does that tell me? It tells me that I need to add acid to the pool. And let me show you an example too of, since the pH shows up as a clear sample, I'm going to drop 2 drops, one straight up and down on a napkin and one off to the side. When I don't hold it straight up and down, the drop breaks off too early. So I've let these 2 dots fall on a napkin, and you can obviously see that one drop is bigger than the other drop. So it's not giving the proper titration of the drop when you hold it off to the side. That's why this thing is calibrated to give you the exact drop size when it's straight up and down. So make sure that when you're testing, I remember back in the day, I used to set my hand on the side of the sample and put the drops in that way, and it would be slightly at an angle just to kind of steady my hand. So you want to make sure that thing is straight up and down when you add your reagents. Now I know that my sample is too high. I need to get the pH down, so I need to add acid to the pool. So if I have two other red caps that are in my box, one is an acid demand reagent and one is a base demand. So this pool is demanding acid. So what I want to do now is add drops till I get that color change back to an orange. So I'm going to add 1 drop, 2 drops, I think is what I did when I first tried it. Let's see if we can get that color change to go from red to orange. Nope. And again, still a little high. So we're going to add another drop, a 3rd drop of acid demand. And a 4th drop. And a 5th drop. And we got our color change to go to orange. So I know the pH is high at this point. So at this point, I'm going to go to my saturation index, and I'm going to put that value directly into the chart here. So I know that it's 7.8, close to 8.0. The temperature of my water right now is running about 76 degrees. And now I've got to check for the calcium. So the calcium hardness test is done in that same big vial, but we're not going to use as much of the sample. We're not going to fill it to the 44 milliliter. We're going to fill it to the 22, half a milliliter. Now I follow the directions on the test kit, and it says I need the sample to turn green for alkalinity to be present. But before it'll turn green and get to the brightest color it can be, I have to neutralize the chlorine that's in the water. So the first sample says add 2 drops of sodium thiosulfate. 1, 2. If your chlorine was really high, let's say it's running 5 or even possibly 10, you could add another drop or 2 of sodium thiosulfate to the sample. All that's going to do is neutralize the chlorine that's in the water. It's not going to affect whether the sample gets more intense or less intense. So I've neutralized the free chlorine using the sodium thiosulfate. Then if I go to the box, I have to use 5 drops of the indicator, and this tells me if alkalinity is present. So I'm going to use 1, 2, 3, 4, 5 drops, and if the sample turns green, then alkalinity is present in the water. And the sample turns green. So I've got the alkalinity that's in the water. Now I need to know how much alkalinity is in the water, and that's where my other reagent, and this is your titrimation or your trimetric testing, is when I get an end point and a start point. So I'm going to start off and I'm going to put 1, 2, 3, 4, 5, and it's starting to change or trying to give me a color change. Still green. 5, 6, 7, 8. Almost there. 9, 10. And 1 more drop should do it. Give me that nice bright color. Once I get no more That's 11. And it got really pink. If I added another drop, it's not going to get any darker in color. So I'm just going to go with that 11, even though I added 12, because my color is not getting darker when I go to that next drop. So if you're having trouble to read. So once I've done that, I now take my alkalinity test and multiply the number of drops times 10. So it took 11 drops. So my alkalinity that I have in the water is 110. Now I have to do my calcium test, and the calcium test starts off the same way, half the sample, and I'll rinse and fill that out and get half the sample again, calcium. So I got the calcium buffer, calcium indicator, and the reagent. So this is the buffer. This is what takes and raises the pH to sequester the calcium. And it's telling me to use, add 20 drops of this to the sample. 6, 7, 8, 9. There's 20 drops, and swirl after I get that. And now I got to figure out how much calcium. So now I'm going to use the reagent tester. Calcium in the water is 5 drops. So 5 drops of the calcium in the sample should turn pink or red. So now I'm trying to get a color change as well. So now I go to reagent number 12. And if it's right, it should take about 16, 24. And I got my color change to the blue color. So now I can do that same math, 26 drops. So it tells me that my calcium hardness is 260, because 26 times 10 is 260. Now, the one thing that the Langelier Saturation Index takes into consideration when you're doing it on a worksheet is the total dissolved solids. So I don't think anybody out there carries one, keeps one, and measures their TDS. And even if they did have a TDS meter, it's something that doesn't really require to be checked all the time. In other words, when I have TDS in the pool, it's the amount of everything. Everything contributes. Wind, pollution, bathers, chemicals that you put in there. The total dissolved solids always start to rise. But what's the lowest it could ever be? And the lowest it could ever be is whatever you fill that pool with. So if you filled that pool with city water, that's what the TDS is. And not city water is never going to be 0 TDS. It varies from state to state, to municipality to municipality. So, but for the most part, most TDS, and Florida's got the worst total dissolved solids. They'll run 300 to 350 off of it. Whereas if you go to Hank's area, Michelle's, Birmingham, Alabama has some of the softer water in the United States, and theirs runs 2 to 250. So if I look at those numbers, that's my startup value. And as I add chemicals to that new water and calcium, and bathers, everything contributes. So what's going to happen is your TDS is going to start to rise. And then it hits a plateau, and when you're backwashing or wasting water, it dips down and just keeps going up. But it rises to one level. So if you want to know what your TDS is, take a bottle of your city water to Pinch a Penny, Leslie Speed, somebody who does some of these free water tests, and ask them what the TDS is of your city water, and then take a sample of your pool and then your pool water. And the difference between those two numbers is the difference that you're looking for. And we'll say the TDS is 900. So I started out at 350 and it's risen all the way to 900. Once you measure your city water, you never have to measure it again. You only measure it once and set it and forget it. If there's any variations, it'll be so small it doesn't need to be deviated. As far as your pool water, I'd have it tested for TDS once a year. You're not going to get that much variation. So now that I have my Langelier Saturation Index, pH is recorded, it is what it is, 7.8. Then we have a factor that we use for temperature. And the temperature factor, if you go to the Langelier Saturation Index chart, it tells me 78 degrees, 76 degrees is 0.6. So I'm going to put 0.6. Calcium factor at 250 is going to be 2.0. And alkalinity factor at 110 is going to be 2.1. That gives me a subtotal. Who's my math guys in here? 9, 15. So I've got a subtotal of 12.5. My total dissolved solids are less than 1,000. So I'm going to use minus 12.1. If it was more than 1,000, I would use minus 12.2. Then the total of that, 12.5 minus 12.1 equals 0.4. And it's telling me now, if you're using the Langelier Saturation Index from the chemist that designed this chart, you are only allowed a balance range from minus 0.3 to positive 0.3. So we're on a positive end of the scale. We're slightly scaling in this pool. So we need to get it balanced. We need to make an adjustment. So if I look at what I need to adjust, I always go after alkalinity. Alkalinity's ideal settings is 100 or 80 to 120. I'm right there in there. So I'm not going to mess with my alkalinity at all. I'm going to keep it at 110. pH for this pool, though, ideal pH should be 7.4 to 7.6. So I need to change that to 7.5. Temperature, we don't have any control over temperature, and even if we do, we don't adjust it. And the calcium is in our ideal range, 200 to 400. We're at 260, so no reason to change it. So I put my new numbers in there. So now if I rebalance the pool, and I made it 7.5, 0.6, 2.0, and then 2.1, we didn't change it. Now our new number becomes 12.2 minus the 12.1, which equals 0.1 water balance. So now we're right there at that 0. We're in our scale from -3 to +3. what I want you to use is this wheel right here. So what you do when using this saturation index is you don't have to do this math. You're going to line up the two readings that we had, alkalinity and calcium hardness. So I find the alkalinity was 110, and I line the 260 up with the 110, and then I go over to this window over here, and I set my parameters where the pH would be perfectly balanced is at 7.4. So at 7.8, where we were at, to be perfectly balanced, and that would be at 76 degrees. Let me find 76 on here. Would be right there at 0, but we're actually at 7.8. So if we go up from 7.4, 0.4, 0.5, 0.6, 0.7, 0.8, that's our 4 difference that we were out of. So that 0.4 that we did in that mathematical formula holds true, but we did it a lot faster just by lining up those two numbers. Because my actual pH is above the line, it's telling me it's scaling. If my actual pH would have been below the line, it would have told me that we were corrosive, that the water was chewing away at the pumps and the shells and the motor. You know, if we do a new pool startup and 6 or 7 months, all of a sudden you get these big pock marks on the side where it's etching and peeling and falling apart, is simply because somebody didn't give the water calcium. And water is naturally aggressive, and what it seeks to balance itself is calcium. And either you give the water calcium, or it says, okay, don't worry about giving it to me, I'll take it. And it takes it from the shell. And that's why your pool starts to deteriorate or fall apart. We want to blame the Marsite guy. He didn't use enough aggregate. He didn't do something right. No, it's because we didn't maintain the calcium in the water. So at this point, we adjusted our calcium, and it took 5 drops of that reagent to go from 7.8 to 7.5. So now I'm going to go back, and if I go to here and I wanted to decrease the pH, and this is in the back of that little booklet. If I want to decrease the pH in this pool, and I'm using muriatic acid or hydrochloric, muriatic acid and hydrochloric are the same chemical, just renamed to make it a little more palatable. And let's say this pool is 20,000 gallons. I go down here and it took me, I think I said 5 drops. I go to where this lines up, and to get that pH down to the 7.4, 7.5 I'm looking for, it tells me how much chemical to add, which would have been 2.66 quarts. So your book, instead of having to do the math and do these different charts that we have to do, we can actually use it. If I wanted to increase my pH and I was using soda ash and I had to use the base demand, I go to the number of drops, line it up underneath my pool volume. In this case, we're using 20 gallons. If I use 5 drops to increase it, it tells me exactly how much chemical to add, 3.20 pounds. If you don't see your pool volume up here, let's say it was 25,000, then I would combine the 20 and the 5,000 numbers, add them together to use that much chemical. If I was adding chlorine and I wanted to make an increase, let's say I wanted to increase my chlorine, depending on the type of chlorine, it tells you how much I need to use. So if I'm using 10 to 12% available or active chlorine, which is your liquid bleach, I'm going to use 1.6 to 1.3 pints of chlorine to raise it 1 part per million. If I wanted to raise it 3, I would triple that amount. If I was using calcium hypochlorite, which is your 60% chlorine, and if you look on your labels, it'll say 60% or 68, whatever ones comes closest, use that number. It tells you how much to use to adjust that chlorine level. But again, that's just for 1 part. If I wanted to make a 3 or 4 part change, then I would multiply that number I see by the number of parts I want to change it. But that Taylor Test Kit booklet is set up so that you don't have to use these mathematical formulas and equations that you would normally have to use when we're doing actual test work or doing it in the field. And let's go to the chemical adjustment worksheet so that we can put this in here. So if I wanted to increase my chlorine level in a 20,000 gallon pool, I put the actual pool volume. It's right there written for you. And I'm going to use liquid chlorine bleach, which is 10.7 fluid ounces, to make a 1 part per million change. My desired chemical change, let's say I wanted to increase it 3 parts per million. So 3 parts per million divided by the 1 would give me the 3. 20,000 divided by the 10,000 would give me 2. Then I could multiply the 10.7 times 2 times 3 equals 642 fluid ounces. So there's 64 ounces in a half a gallon, or 128 in a full gallon. So it's telling me to make a change of 3 parts per million to add a half a gallon, or 64.2 ounces. And we divide that by the number of ounces in a gallon, which is 128, equals 0.5. So it would equal 0.5, or a half a gallon of chlorine, to make that change. Again, no reason to know that worksheet. You have your Taylor test kit, and to make those adjustments, all those charts are in the back of the test kit to make it simple and easy for you to make these adjustments and changes without having to do these mathematical formulas. But I think the girls in marketing, again, already get a hold of this stuff and immediately put it up online. So there's a way, if you want these worksheets to figure out for your pool, if you feel comfortable doing that, you can download those and use them for your pool. Once you start making changes, I know my counterpart, Randy, made a good comment the other day, is in the backpack. If you happen to have a backpack, lift it up, take a Sharpie marker, and write down how much that chemical changes it. So once you've done the formulas, the person that you're training or working with doesn't have to go to you every time to say how much to make that chemical. It's already a little footnote that's written into your backpack area. But both of these sheets, the chemical adjustment worksheet and the balance worksheets, are there. But again, you have the saturation index with the wheel that will do it for you, that does the balance really quick, really easy, or you can do the worksheet, but both of them give you the exact same numbers. I can't emphasize enough on getting your customers, or if you're actually a maintenance person, to focus on water balance rather than just trying to go after pH and chlorine every day. If you focus on that water balance and you start to understand that everybody's pool is going to have a tendency to do something. Some people may have a pool where there has a pH that constantly rises all the time. Then overcorrect it down to the low end and let that demon take it up. Or on the same token, if you're using a type of chemical that drives your pH down, then you want to take it to the high end of the ideal range and let it drive it back down. So that way you're only adding chemicals to the pool once or twice a week rather than chasing perfection every single day. Again, I get it, but I'm just trying to find ways of getting you more time to do other things, since our main focus is not the swimming pool. And springtime's here. If you haven't thought about it, now's the best time with all the pollen, and your agronomics is going to start with fertilization. Get with your Chadwell supply rep or your vendor who you buy and start getting some algicide to prevent the blooms that always happen right at the beginning of startup season. So my suggestion is always use the polymetric or the copper-based algicides. They work really, really well. We have a good variety of different ones. Just remember, an algicide is a preventative. It's not a treatment. They do sell treatments, but I'm looking for you before you get algae. It's far easier to prevent algae than it is to remove it. And the #1 most cost-effective thing that you can do to prevent algae is brushing your pool and walls on your pool or spa on a routine basis is a very, very important preventative measure, and it will keep the algae down. But if you're having a struggle with that, the algicides will take up a lot of that. And again, my recommendation is always go with the heavier metals, but also follow the directions. If you don't use them correctly, you could stain the pool if you do not follow the directions, but they're clearly written on there. They all want elevated levels of chlorine when you add any type of algicide. So